Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at EDB. I will be your host today for our webinar, Automating a PostgreSQL High Availability Architecture with Ansible. I'm joined today by Mark Linster, our Chief Technology Officer, and Vibhor Kumar, our Chief Performance Architect. Before we get started today, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 1 hour. We expect the presentation to last most of our time, and we will allot any extra time for Q&A. If we do not have time to address all our questions, we will follow up afterwards with any attendee whose question was not answered. Now, without further ado, I hand it over to Mark and Vibhor.
All right, good. Hey, thank you, Molly. And let's move forward. So to the agenda today, what we're going to do is we're going to spend a wee bit of time, just I promise, very, very brief on introduction to EDB. And then we'll start with, concepts of high availability, because that's what our automation subject is going to focus on today, right? We don't want to just show you how to deploy Postgres. It's important, but it's not very hard. But here we want to talk about how you can use things like Ansible and Terraform to get a highly available architecture deployed. Then Vibhor is going to walk us through the concepts of Ansible and exactly how to do that, and point you to the repositories and Ansible Galaxy, where all of this code is available under Postgres license. Okay, so basically at the end of this, you should be positioned to completely create highly available Postgres architectures using certain reference architecture models in very, very short time, and doing that in an automated fashion. Okay, so let's go forward. Bear with me here. We're going to talk briefly about EDB. We are today the largest dedicated Postgres company. As you may know, on September 30th, we acquired Second Quadrant. So that gives us more customers, more experts, and a greater drive for innovation than any other dedicated Postgres company. We're very, very happy that this was happening. We've been working on Postgres together with Second Quadrant and many other companies for many years. And so this is a great getting together that will allow us to drive innovation even faster. Okay, let's go forward. So really our mission is here, we supercharge Postgres. Together with our colleagues from Second Quadrant, we are now bringing lots of customers to the mix, lots of employees that are focused on driving the technology forward. In fact, hundreds of people who are working in product engineering, in support, in remote DBA services, etc., to make sure that customers get the value from Postgres that they could get. Okay, and then the other thing that I want to emphasize is, Gartner has recognized Postgres, especially EDB Postgres, in the Gartner Magic Quadrant since the Magic Quadrant has been published again. So for many years now, we've been in the Magic Quadrant. And what's really important is today, EDB Postgres is the only open source relational database that is in the Magic Quadrant. Okay, let's go forward, please. Okay, and as I said before, we have more Postgres experts than I think anybody, not just I think, than anybody else in this market. So we have over 300 technologists, 26 Postgres community contributors and committers, and then big names that anybody who works with Postgres knows. I mean, Mike Stonebreaker is an advisor to the company today. Mike was the creator of Postgres many years ago when he was in Berkeley. Bruce has been the driver of the Postgres community now for soon to be 25 years. Peter and Robert, notable architects and contributors to Postgres, and then Simon Riggs, the CEO of Second Quadrant, who's now joined us as an employee and Postgres fellow. So we really have a wealth of expertise, not just from developing Postgres and participating in the Postgres community, also gained from working with literally thousands of customers over now 16 years. Okay. So now let's go into a first poll here to help us understand which automation technology you use today. So please fill this in so that Molly can share the results with us, and we can pick up any of the things that we learn in here in the rest of the conversation.
Yes, we'll give everyone just a little bit of time. I know everyone is seeing the options from Terraform, CloudFormation, Ansible, Chef, Puppet, Sol, any others that aren't listed there. Already in the first 30 seconds, we already almost have 50% of the audience vote. We're getting a lot of votes in here. We'll give it another 5 seconds for anyone else who wants to vote, and then we'll share the results. All right.
All right, that's interesting. Okay, and this is going to align really, really well with what Vibor is going to talk about in the second part of the talk here, where we see clearly Ansible and Terraform in the lead. We're going to show you how to do this with Ansible and Terraform and the Postgres licensed deployment scripts that are available on our repos and in the Ansible Galaxy are leveraging Ansible and Terraform. Chef and Puppet, that's interesting. I would have thought that they would be more comparable as far as the population goes. Obviously, CloudFormation, more Amazon focused. Yeah, Salt, something that we use internally in our IT infrastructure, but is not that prevalent anymore. So, Vibor, anything you want to say here?
No, I think this is pretty much aligned with our survey too. I think Terraform is the answer. Terraform and Ansible both are the first choice of the people. The people prefer to use Terraform for provisioning the resources in the cloud, and they use Ansible for deployment purpose. Some people actually go purely with Ansible because Ansible also has a lot of modules and capabilities which people can use to create resources in a specific cloud. So this is really validating the fact which we got right from our survey in June. So this is pretty awesome.
Great. Okay.
All right. I know we have a second poll, launching it right now. Question is, which connection pooler are you using for your high availability architecture? PG Pool, PG Bouncer, PG Aggro, application connection pooler, or others? If you're using something other than the ones listed, drop that into the chat. Let's see what you're using outside of the one we have up there right now.
Okay, thank you. And we know that, you know, if you're in Amazon or so, then you may be using different connection poolers or connection managers. So it's interesting. Would be interesting for us to get some input here. Obviously, PG Pool, PG Bouncer are very, very popular, but PG Aggro is also nothing to be sneezed at. So be interesting to get that data and share it here with everybody.
Yeah. Give everyone another 2 seconds to answer. We have just a little, we're 50%, and we'll share the results.
Interesting.
Interesting. Yeah. So, I mean, this is good to see. I mean, PG Bouncer is obviously the functionality between PG Bouncer and PG Pool is not 100% comparable, right? PG Pool is also a query router, not just a connection pooler, but PG Bouncer is significantly more lightweight and so often a preferable model if you don't need the horsepower of PG Pool. PG Aggro, we would have expected some use and not like no use. Okay, Vibor, what do you think?
I think this is pretty good. I think for PG Aggro, I believe it's expected because it's very new technology, right? And others, I would like to understand what others are using it. But PG Bouncer is really popular. PG Pool, very interesting to see how people are using PG Pool. So it's good stats are giving us some information that PG pool, PG bounds is still leading the connection pooler uh, management or connection management in highly available architecture.
Okay. All right. Thank you. So I'm going to turn it over to Vibor now to take us through the automation for highly available Postgres architectures.
Thank you, Mark. So before we begin, let's understand the high availability. I think I've covered this in the previous webinar sessions too, but just want to refresh our knowledge exactly what does high availability mean, right? And exactly what it covers. So again, again, it's a characteristic of the system which is purely focused on the agreed level of the operational performance, which we generally measure in terms of the uptime, right? And we ensure that system is always up and running for the users, for the customers, or the for providers, it to be a customers or the clients who are using their services. Availability generally we express as a percentage indicating how much uptime is expected from a particular system or component in a given period of time. Generally, people measure the availability in the percentage, and based on percentage, they define the number of hours, or number of minutes, or number of seconds they have for the downtime. The main three key principles of the high availability is one, first eliminating a single point of failure. That is, in case something happened to the one node, other node should be available, or there should be redundancy in the system so that it can take over on the failure nodes. Second, there should be enough reliable crossover so that you don't lose any data, and there should be automatic switchover between the systems, and there should be a mechanism to detect this kind of failures. So these are the three key principles of the high availabilities. As I mentioned, high availability always measures in the percentage. You can see when we say 99% of the availability, it means maximum downtime per year you have 3 days, 15 hours, 39 minutes, or 29 seconds. Again, 3 days, you can think about overall year, 15 hours in a month, 39 minutes in a week, and 29 seconds in a day. In the same way, if you go to 99.9%, you have something similar, 8 hours, 45 minutes, or 56 seconds you have in a week or in a day. So if you target for the, let's say, 5 nines, you can think about you have only 5 minutes, right? The key part which you would like to see is that when we talk about the target availability in the high availability concept, it's not really a guaranteed availability. It's where we are focused on, we are working towards to provide that kind of the availability. And again, availability is always get affected by the many different parts of the system. That includes operating system availability. In case something is wrong with the operating system, then of course service will get down, right? Also, a certain level of dependencies around the hardware, network, and the environment in which you are running the system. Like for example, if you don't have a proper cooling mechanism and your system is pretty much hot, right? Then that could also cause some kind of a server downtime. So you need to make sure that that is also there. And again, there are other services which you would like to include, maybe upgrading your services or maybe performing some maintenance operation that will also impact the high availability. So again, as I mentioned, that target availability is pretty much focused on that we are focused on the how much you want to achieve out of your system, how much you're providing to your users. There are some best practices to calculate the high availability. And here you can see this is the one formula which I got from the mygoal.org, which has the formula for calculating the availability. It's purely based on the agreed service time, how much downtime you want to keep it for yourself for the maintenance operation, or for upgrade, or for patching or anything, right? And then again, agreed service time, which is again it's a time which you have defined in your SLA or service level agreement which you have with your customers or with your users. So are you really using the services, right, or the platform? Important thing is that whenever you are measuring this high availability, you should always keep in mind how much planning and the deployment you will need to have or time you need to have for your services. Because in case if you reduce the time for your maintenance or the upgrade, you may not be able to give more up-to-date services to your customers. So again, this is a generic formula which you can use to calculate the high availability. In the high availability, there are some other concepts and which are the key components. And as you know, the recovery point objective and recovery time objective. Again, recovery point objective is a measurement of time from the failure, disaster, or comparable loss causing events, right? And it can be used to measure how far back you can go, right, to recover your data, to recover a usable data and make it available for your users, right? And it also dictate exactly how frequently you should take a backup of your systems so that you have less or least data loss during the disaster or during any failure or any problem on the system. So again, recovery point objective, you can see the line which is talking about how far you can go. You can go back to 15 minutes, 2 hours, totally up to the up to exactly how frequently you're taking the backup and kind of the availability of the architecture you have deployed for your services. Recovery time objective is actually the amount of time an application is going to take or recover from that disaster, right? Again, that includes the steps you would like to perform after the disaster and how you can bring your services to a consistent state. That includes the data and everything. And that's why you can see you can have recovery time object to the 5 minutes, 7 hours, depending on the SLA you have defined or you agreed upon with your customers or the users. These are the key important pieces you would like to consider when you are defining the high availability of your system. There is other concept called GRO. Again, it's a geographic redundancy objective or geographic recovery objective. Both terms are very well known. It's kind of a recovery point objective. It includes actually RP, RT, or both across the geography. Something happened to your one data center or data centers into one region. How much time would you take to recover the services across the geography? So this is also a very well known concept in the high availability, and people do actually maintain the GRO or recovery point objective or recovery time objective across the region. So after covering the high availability, now let's understand the reference architectures, because again, these are the architectures going to help you to achieve the high availability, whatever you want to achieve, right? There are many reference architectures, but people need to understand what does a reference architecture mean, right? Again, reference architectures are pre-designed, tried and tested templates and deployment patterns for users. These architectures actually define as a different level of abstractions from the deployment point of view. Again, you should always consider the reference architecture as a starting points, and you can add more components in the reference architecture to meet your special needs or whatever services you want to add on top of the core reference architectures. Again, it's a foundation. It's purely focused on the, right now it's purely focused on the database server side, and other capabilities which you want to add, you can add it. Like if you want to add a connection pooler in the mix, you can add that. That's where the server is really going to be useful for us and how we can actually help you to achieve those add-ons with the core architectures. So core PostgreSQL architectures, again, this is kind of an overview because I'm going to focus mainly on the automation part. So the main, there are three different core PostgreSQL architectures or reference architectures. One is called single node. Other is multi-node cluster, where you can have a primary, standbys, or replicas with asynchronous replication between them. or you can have a one primary and replicas with synchronous replication. Again, all these different core PostgreSQL architectures gives you different level of the high availability or can help you to achieve a specific target availabilities, right? Now, the first one is single node. In a single node, again, you will have a one server, as the name suggests, you have a one server, one node, and you can have a different volumes for your data directory, for your wall, which is the write ahead log file, or if you have a table spaces, those can also resides on a different volumes. So you have only one instance, and all the volumes are attached to that particular server or the node. An application are pretty much connecting to that particular node. A lot of people use it for the systems which are not mission critical or not mission critical applications. They use it, this single node architecture. Again, this depending on the database size and backup strategies, you can define your RTO. RPO is again very much dependent on the backup strategy which you have. Like if you are going with the BART backup, or if you're taking snapshot level backups, those can give you a different kind of the recovery time objective and recovery point objective. This particular architecture doesn't cover the GRO, that is geographic redundancy objective or geographic recovery objective. It gives you 3 level of nines target availability. You can actually use it in production system where you can think about something happened to your one node. If you have a virtual machine, you can create a kind of automation where you can spin up a new virtual machine and assign mount those volumes so that you can make your system available all the time. The other core architecture is multi-node with asynchronous application, right? Here you can have one primary and you can have multiple replicas. Primary can serve your read and write connection both, and replica can be used for your read workloads. Or let's say if you are planning to do some kind of a data mining or some analysis on the data, you can really use your replicas. It's pretty much up to date. The recovery time objective which you can achieve through this particular core architecture is less than 60 seconds. Again, recovery point objective can be in few seconds because it's mainly a switching between primary to the new primary. I'm promoting a one replica to be a new primary in case of the disaster. You can achieve up to the 4 nines or you can achieve up to the 5 nines, totally dependent on the reliability of your infrastructure and plus the tuning which you can perform on the automation where in case of the disaster or in case of the failure of the primary, how quickly you can promote the standby or the replica. The other one is, again, it's a multi-node with synchronous replication. Here, it's similar to the one which we saw in the previous slide. You have a one primary and you can have a two synchronous replica. You can have a one synchronous replica, totally up to you. Recovery time objective is less than 60 seconds or maybe near zero data loss you can think about, right? Recovery time objective is less than 60 seconds because totally dependent on how fast you can actually promote one of the replica to be a new primary, which can take the workload. Recovery point objective is few seconds or maybe near zero data loss because it's a synchronous application. Whatever you're writing to the primary is also getting replicated instantaneously or immediately to the standby replica. With this architecture, you can get 4 nines, 5 nines. In some situation, people got 6 nines too, depending on the infrastructure, because it also depend on the it's also depend on the how quickly you can identify those failures and how quickly you can promote one of the replica to be your new primary. Now, I think we have gone through we have seen all the different core architectures, right? These are key core architectures, and if you want to add components on top of those core architectures to meet your special need, you can do that. There are many add-ons available on the core architectures. Now, key question comes how you can automate or how can you automate these architectures in your environment, right? Because automation is a key thing. For automation, there are many tools available, right? You can use any one of those. Terraform, CloudFormation, Ansible, Chef. But there are some decision factors which you should always keep in mind. You can say each technology has some trade-off, some advantages, some disadvantages. Let's start with the some key factors here, right? One is called configuration management versus provisioning. Do you really want to manage the configuration of the system or not? That's also a decision factor. So do you completely focus on the provisioning of the system, right? These two are the important, I would say, factors you should consider while choosing one of the DevOps tool or deployment tool which you would like to use. Procedural versus declarative. Do you want to do a lot of coding around the tool to meet your need for the automation? Or do you want to go with a declarative way of just creating a task which can be executed on the system to deploy the architecture? Master versus masterless. Do you want to have a system or common server where you are managing the configuration and everything, and agents are pretty much running on each and every machine and taking the instructions from the common server? Or do you want to have a system which can simply just deploy, create those architecture for you, or deploy the architecture for you and make the system available for your services and for your users? Mutable versus immutable. Again, this is another topic which you would like to consider, where you would really want to maintain the state of the machine, or do you want to simply provision the systems or deploy the architecture and make it available for your user and maybe tear it down after the use, right? And again, the agent versus agentless, like Chef, Puppet, Salt, Stack, right? Or these are pretty much agent-based softwares where you have a common server or one server, which we call it as a master or the primary server, from where these agents get the instruction and accordingly deploy the software on a target nodes or target machines where they are running, right? And Ansible, CloudFormation, all these are pretty much agentless, where you can simply run from one machine and provision the systems or deploy the architecture quickly. There are the other factors too, which you would like to consider, like supportability, whether these projects are pretty much supported by the large community, small community, how much these technologies are pretty much mature, right? And how frequently these technologies are getting the cutting edge features which you can use or leverage in your environment, right? So keeping all these thoughts in our mind, right, we decided to choose one which I think the survey which we did, which also validated the fact that why we chose the tool technology for the deployment or for automating the deployment of the core architectures. We also did one survey in June 2020. In the survey, we asked our customers what kind of a DevOps tool or the automation tools they are using for deploying the Postgres at scale, right? And this is the result which came up, which is pretty much aligned with the survey which we did before our talk, right? And you can see Terraform and the Ansible are the most popular one, and most of the people are really using it in their production environment. So before we get into the different kind of tools and the modules which we have for our customers to deploy the core architecture, let's try to understand what is Ansible, because again, this is a kind of an overview for the new users who are attending this session. Again, Ansible is a technology which can help you to automate the deployment and configuration of any application or infrastructure, right? Again, it's a very well-known tool. There are 4 levels of abstractions available in the Ansible. One is called task. Suppose if you want to perform a specific task, that is single action, that is called task. You can combine those tasks together and call it as a task list. You can put that or feed it to the Ansible to perform those tasks or list of tasks on a specific server or in a specific environment. you can combine these tasks and create a one group that is called role. I mean, again, these tasks are pretty much related to a specific action or the activity you want to perform on a specific server. And the third abstraction layer is called playbook. Playbook is mainly is a playbook is the one which you feed to the Ansible to perform or perform a specific task, or you can actually combine the roles and tasks together and create a playbook or play list of plays which you can feed to the Ansible to perform those action on a specific nodes or in a specific environment. There is one more concept which is very, very well known concept called collection. Again, this is a very new to the Ansible community because this happened this year. It's a new concept introduced by the community called collections. Again, collections is a way of packaging your all playbook, roles, modules, and plugins together so that you can distribute, to your users or to your internal users or to your customers. So that's called collections. And EDB has its own collection too, which is pretty much available in the Ansible Galaxy. We do have a repository. You can see the link here, which you can find into the github.com. The collection which we had created can help you to configure a single node and multi-node cluster in any specific cloud or infrastructure. Ansible is pretty much can help you actually deploy these core architecture in the on-prem environment and in the cloud. This, as I mentioned, that this is available in the Ansible Galaxy. And as you can see, maybe the image is not pretty large enough. As you can see, community has given us 5 out of 5 score on the work which we have done on the collections. With this collection, with this Ansible, with a single command, you can actually deploy the core architecture in your environment. So you can see this is the one single command where there is a playbook.yml file. You're passing your operating system user, you're sharing your key, and Ansible will automatically connect to those servers and will deploy the core architecture, whatever core architecture you choose to deploy for your customer or for your own use, right? Again, it's totally dependent on the high availability or the SLA which you have signed with your users. In this, you can see a playbook.yml file, which contains all the task list and the plays which its Ansible is going to perform on the node. There is a user, a CentOS user, again, depending on the operating system. Again, it's a privileged user which has sudo privileges, and you can use that user of the nodes, and you have to pass the SSH key so that Ansible can use this SSH key and the user to connect to the remote machine where it can deploy the core architectures. And this is the example of the playbook. In the playbook, you can see roles are there, and there are some important variables which you would like to set. And the variables are like operating system, what our target host machine contains, whether it's a CentOS 7, CentOS 8, or Red Hat 8, or Red Hat 7. Which version of the Postgres do you want to deploy, right? You can mention 10, 11, 12, because those are the tested versions. What kind of a Postgres you want to deploy? Do you want to deploy ADB Postgres Advanced Server, or do you want to deploy community version, PostgreSQL, right? You can choose, you can say EPAS or PG. Then again, if you're deploying with that, you need to pass the yum username and the yum password, which is again, you can get from the ADB website. ADB has a repo. From the repository, it pulls all the packages to deploy on the system. And you can see there's a collection, and the collection name is adbdevops.adb Postgres. And this collection contains many rows, like setup repo. Setup repo is meant for setting the repo on the repository on your servers. Install DB server is for installing all the DB server packages on the servers. Any DB server is very specific to the primary node. So as you know that in multi-node architecture, you may have one primary, multiple replica, or if you're going with the single node, you will have one primary only, right? So any DB server is only for initializing or creating that node as a primary node. Then there is a setup replication role, which actually ensures that your replica is pretty much ready in the multi-node core architecture. And with that, it also deploys some additional pieces like setup EFM. It set up the EDB failover manager, which makes sure that it can detect any kind of a failure and accordingly promote one of the replica if you have deployed the multi-node architecture. In the same way, there is a Postgres Enterprise Manager for managing or for monitoring this whole architecture which you have deployed in your environment. And we have also managed DB server, which allows users to do certain kind of a management for a database server with the deployment, which I will be covering in the few slides. So in the playbook, you must have seen there is a one important variable file called host.yml, right? This host.yml file is the way you can actually pass on the server information to the Ansible, and Ansible will, according to those information, will go and deploy the core architecture. Here, if we are talking about here, you can see in the example, it's a multi-node architecture deployment, and it's a you can see it's asynchronous and asynchronous both. In this, you can see host.yml file contains some information like PEM server. There are some properties you can see. The PEM server node type is a one property which tells you that whether it's a PEM server or some other server, right? You can give the public IP address where it can the Ansible can connect using the public IP address to the server. If you are deploying the multi-node architecture on the on-prem, right? In that case, public IP and the private IP address can be same, right? But if you're deploying in the public cloud, there the public IP address is the way to communicate to the server, and the private IP address can be used to communication between the servers, right? So that's why the public IP address is there, private IP address is there. You can define the node type primary, and you can mention whether you want to deploy PEM agent, which is again a monitoring system with the primary deployment. You can say PEM agent equals to true. You can pass on a public IP address and the private IP address. The same fashion, you can define the standbys or replicas. The node type will be a standby, and you can mention whether you want to create a synchronous replica or asynchronous replica. It's totally up to you, and you can define a property called replication underscore type. So you can see it's a very formatted host.yml file through which you can pass the information to the playbook, and based on the playbook, Ansible will be able to deploy a core architecture in your environment, whether it's a multi-node or single node. So let's look at the single node architecture. In the single node, you can see the playbook has less number of the roles, right? Because you don't need setup EFM, setup PAM, or setup replication. You just want to create a one node, right? And in your host.yml file, you're passing the one node information. We are saying that node type is primary, and this is my public IP address, and this is my private IP address. With that, you're also telling through the playbook, you're telling to Ansible that, hey, I want to deploy my operating system is CentOS 7, and the version which I want to deploy is 12, and the PG type is EPAS type, EPAS, which is EDB Postgres Advanced Server. With these information, with one single command, Ansible would be able to deploy a single node architecture in your environment. But let's say if you want to go with a multi-node architecture, right? Multi-node synchronous architecture or asynchronous architecture is totally up to you. And the YAML file which will contain will have these information. In this case, you can see that the user decided that they don't want to deploy monitoring system. They want to use something else, right? And that's why he just want a primary and replica. Multi-node architecture should be deployed. But in case if you want to deploy full-fledged architecture with monitoring automatic failover, you can simply change your host.yml file and mention that PAM agent equals to true, and it will automatically go and deploy every component which can make your system highly available. Again, there are more features in the Ansible collections, which we have already published in the Ansible Galaxy. As we mentioned that this is also available in our repository. there are other features which you can use with the Ansible collections. Like, for example, with the deployment of this multi-node architecture, if you want to create a specific user, right? Like, for example, for a specific application, you want to create a user, you can set the variable, or you can set these variables into the playbook, and the collection will automatically go and create a user. If you want to grant a specific privileges, if you want to grant a specific rules, you can do all those management of a database user and privileges with the Ansible collection, which we have published. And again, you can see it's pretty much straightforward and well formatted, easy to read, easy to write. All the naming convention which we used for the collection is that people can understand automatically. Like, for example, con underscore limit, which is connection underscore limit, number of connection you want to allow from a specific user. With creating managing the users and managing the privileges, you can also do more with the collections. For example, if you want to set a specific parameters, right, while deploying, with deployment of the core architecture, you want to set a specific parameters or tweak the parameters for your performance of the system, right? For example, if you want to set the parameter of the maintenance work map to 128 megabytes, you can do that easily with the collection. With this, if you want to manage the HPA or host-based access, whom you want to allow to make connection to your multi-node highly available Postgres architecture, you can actually control that using the PG HPA IP addresses, where you can mention what kind of a connection type is. You can mention the users whom you want to allow. You can see whether you want to disallow or allow. In disallow case, state will be absent. If you want to allow the connection, state will be present, right? With that, if you want to create a specific database for your application, like, for example, if you are developing an application which is going to use geospatial capability of the Postgres, you can create a database called ADB GIS, right? And you can install an extension called PostGIS, which comes with the Postgres. With this, if you want to use replication slots for your for your application purpose, or for the backup purpose, for archiving purpose, you can define or create those slots using the PG slots variable. It allows you to create a physical slots and logical slots both. Again, logical slots are capability in the Postgres, which allows you to do a logical replication between the nodes. Or you can actually decode the wall file to extract a specific information for your application. With this, with the deployment, suppose you want to execute a specific query, right? Or if you want to put some seed data into your architecture, you can do that easily with the collections. There is a PG query through which you can execute the queries. You can copy a SQL file from your local machine to the nodes for execution. You can execute a SQL directly. And let's suppose if you want to manage the PG pass files, right? Again, PG pass is a way to manage the passwords on the server itself, so that the application or the services which you're running on the Postgres on the server can make connection to the database without prompting a password. PG pass is a way to pass that password to the application so that it can connect to the database. You can do that easily. You can manage those easily with the collections which we have. With the Ansible, we do have some more tools or scripts which you can use for the deployment of Postgres in a specific cloud, right? Let's say if you want to deploy the core, I would say core multi-node architecture into a specific cloud, you can do that using the Postgres deployment tools. Again, Postgres deployment tool or in the specific cloud, again, it's a repository available, publicly available under the PostgreSQL license. You can simply download and use it. This Postgres deployment tool uses the two different deployment tools called Terraform and Ansible. Terraform, we use it for creating the resources into a specific cloud. Let's suppose we want to deploy or create a one highly available cluster into the AWS server, right, or AWS cloud. So Terraform will be able to create those resources, and Ansible will be able to deploy the core architecture of the Postgres on those machines or resources created by the Terraform. It's a very thin batch CLI available for the users. There are many options available here. You can actually provision or you can deploy multi-node architecture into the AWS. You can deploy in Azure or Google Cloud. And for each cloud, there are two different commands available, three different commands available. One is for AWS server, create or destroy. You can mention project name. So you can have a multiple core architectures or multiple PostgreSQL servers are running into the AWS cloud with the different project names, right? And you can destroy it after using it. After creating the servers, you would like to deploy the core architecture. For that, we have a specific command for each cloud called AWS Postgres install, which actually deploy the core architecture which we discussed, core reference architectures on those machines or resources created by the AWS server create command. Again, this is pretty much available for your use. It's open source project. If you have any questions or any feature enhancement request, we can definitely work on adding those capabilities into these deployment scripts or tools which we have created for your use. You can open issues with us. You can explore more. In case if you have any question, you can reach out to us anytime. It's a way of automating the deployment of Postgres in the public cloud. So in short, we have some core reference architectures, right, which you could use to create highly available PostgreSQL in a specific cloud or in on-prem. And these core architecture can help you to achieve the high availability defined to a specific NICE based on the SLA signed with you and your customers or the users. Again, remember, this is just only a basic architecture foundation of the whole architecture. On this core architecture, you can add your own components. You can tweak, change it as per your need. These architectures are also available on the GitHub repository. You can see we have a GitHub link here, EDB reference architecture on GitHub. We have the repository links here available for your use. EDB Ansible is also available in the Ansible Galaxy. You can simply go to the galaxy.ansible.com and search for the EDB DevOps or EDB. If you type EDB keywords, you will see the Ansible Galaxy will show you our EDB Postgres collections. Postgres deployment tools, which we discussed just now, the overview I gave you, right? It's also available in the repository. And the link is here in this conclusion slide. And you can simply go and play with it, try it out yourself, and you will see how you can easily create highly available architecture of the Postgres in a cloud or in on-prem or any environment.
Great, thank you so much. We can dive into some Q&A today. We had some really great questions come in. The first one that I'll ask you is, with a replica architecture, what other backup strategies do you suggest?
So with replica architecture, I would recommend you to use backup strategies, backup of the primary instance too, archiving the WAL file with backup, right? Remember one thing, replica is giving you high availability, making services, helping you to make the services quickly available in case of any disaster. But the backup would really help you in case of your region or something happened to your all possible situations, right? So EDB provides a specific tool called backup and recovery tool, which allows you to take the backup block level incremental backups, which can really speed up the backup of the system.
And Vibor, let's not forget there's other aspects to backup, right? We all think about backup in case of disaster, right?
Yeah,
Server goes down, DBA makes a big mistake, but there's also long-term data corruption, right? A
absolutely. Yeah, yeah,
may have snuck in 2 weeks ago, right? And you didn't know about it. You know, somebody made a mistake, corrupted a file on disk, and you didn't know about it, right? That's the first thing.
correct.
Second thing is backup is also for compliance purposes, right?
Right.
Companies require backup retention policies that, say, hey, every day for this week, every week for another 6 months, every quarter, and then, if it's personnel data in the US, 7 years. So, it's not just disaster recovery, right? But for disaster recovery, what Vibor outlined is absolutely right. But then there are all these other requirements that play into backup strategies.
Yeah, absolutely. And that's why you always need a backup and well-tested backups because human error, compliance, right, all those can be recovered through these backups.
Yeah. And then, working with experts like what we have on our team, you would learn how to really take advantage of the Postgres features, right? A few of our customers use time delayed replicas.
Yeah,
You may wonder why. Well, all of us who've been DBAs, well, I shouldn't speak for other people, I can speak for myself, had the DBA oops moment, right? Where they made a mistake, they blew away a table. And if you have a delayed replica, you can just go to the delayed replica during the delay and get it back, right? So,
yeah,
we have a big customer, really large databases. They have always a 45-minute delayed replica to protect them against exactly that issue. So it's not just replication in case of failover, it's also replication to protect against errors and corruptions, but then, as Vibor said, also the backup aspects.
Okay, great. Another question that we had come in was, is EDB deployment secure by default?
yes. So the Ansible module, which we discussed, right? ADB deployment uses the Ansible module and it creates these certificates and also creates the random 20 character password to make it secure. Uh, so when you're deploying the core architecture using the EDB Ansible, you will have a secure system where data between the nodes are pretty much encrypted and flowing in the encryption format. So encrypted format. So so it's pretty secure, and the password which you receive is a random 20 character password, which you can keep it yourself, or maybe you can create a different user for your application users. So it is secure and you can use it in production too.
And Vibor, I think there is possibility to automate the creation of certificates and things like
Yes.
that.
Yeah, and this is pretty much automated in our collections,
Yeah.
and it automatically creates those certificates and enables the SSL and everything.
And then
Okay.
if you look at the Terraform scripts, you'll see how they work with the VPCs, et cetera.
Mhm.
So all those aspects can be done through scripts.
All right, keeping on the topic of deployment, we had an anonymous question that said, is Ansible Playbook publicly available for community Postgres deployment?
Yes, you can use our ADB. It's publicly available. The repository which you can see here and the link which we have shared, it's open source. You can actually download and use it. You can use it with the community version, and you can also use it with the ADB advanced server version, both the versions.
Okay. Another question we had was, in multi-node sync architecture, how is failover automated to achieve RTO? And then secondly, they asked, is there any separate utility to achieve and any other server requirements?
So ADB collections actually deploy the ADB failover manager, which actually helps you to achieve the RTO from the core architecture perspective. It's tuned in the cloud and it automatically detects any kind of failure and accordingly makes one of the standby to be a new primary. So it takes care of that. So we use ADB failover manager in the architecture deployment. And the Ansible which you're going to use by default uses the EDB failover manager.
Okay, I think we have time for one more question. And someone asked, does EDB also secure data in transit during replication or only at rest?
We secure data in transit. Data at rest totally up to the user because they can encrypt the volume. But data in transit is pretty much secure in the core architecture deployment using the EDB Ansible.
Because, I mean, Vibor, it uses TLS, right, to
Correct.
secure the streaming replication, right?
Right.
Okay. We had a ton more questions come in as well that I think might need a little bit more elaboration, but I want to thank everyone for all the questions they asked. I apologize for those questions that we're not going to get to today. Thank you all for joining us for the webinar. We will be sharing the recording along with the slides with you as soon as possible, and I hope you have a great rest of your day. Thank you.
Thank you, everyone. Thank you.